Hello students, let's start the lecture of kinematics and theory of machine. Myself Professor Shailesh Patel, and we are going to continue chapter belt drive. And in this lecture we will cover the topic is length of open belt drive. Okay, so we will derive the equation which is used for all the example of the belt drive. Okay, let's start. Okay, let's start length of open belt drive, which is very important theory from the belt drive. So first of all, in this theory we will find the length of this belt between two drives. Okay, you can see there is a pulley is here and B pulley is here. Distance between both pulley is x. Okay, and you can see radius, this is the r1 and this is the r2. Okay, so between these two pulley, what will be the length of the belt? Okay, so first of all, for this length I am going to show you the point of contact between the belt and pulley. You can see here, you can see this is the point where belt is touching the pulley, first point. So I am giving the name as a E, and same belt is touching here. In this figure you can't see because this is a smaller pulley. Point of contact between belt and pulley will be after 90 degrees. So it is, I am giving the name F. Same as you can see here, this is the point, and same as here. Again give the name G and here H. Okay. So with respect to center, the point will be at a here like this. Okay, so first of all I can say that the length of belt is divided in this arc, this length EF, then again the arc, and this length GH. Okay, so first of all, R1 and R2, radius of larger and smaller pulley. X is the distance between the center of the pulley, and L is the length of total belt. Okay, so we will find the arc. I am giving the name here. Here, I am giving the name G and A. Okay, so this total length is divided in this arc G, G, J, E, and F, K, H, and EF and GH. Okay, but I can say that I can simply find this by dividing this total length in two. So I can find this total length in this way also. So I will find the arc JE first, then EF, and this is half arc FK, and after multiplying the two I can find the whole length of the belt. Okay, so this is a very simple method to find. So for that, for find any arc, what is the formula for the arc? Arc is equal to radius into angle. So what is the JE arc is making angle with this pulley? What is the angle? Means 90, this 90 plus something angle is there. Okay, name it that point. I am giving the name of this as a alpha. Okay, so E, contact point making alpha angles with vertical line, so same angle will be here alpha. Okay, so this alpha to alpha angle you can see here, but what will be the angle here? So same angle will be there, because this point of contact is a the distance is covered in this direction, same will be here, so there will be also alpha. So there at all four angle will be alpha. Okay, so after that I want to find the angle alpha. How can the find the angle alpha? So first of all, if you want to want any angle, you have to one right angle, so you can find the alpha. So first of all, what I will do, I can say check here, there is a EF length, and parallel to EF, from this center of this smaller pulley, I will draw the line, and it will be perpendicular to here. Okay, because this line is also perpendicular to EF. So from this I can, same alpha angle will be here, and from this triangle I will find the alpha angle. Okay, so check this total drawing from your book. You can check here, this is the alpha angle here, this is the same alpha angle at all 4 points, here will be alpha also, and you can check this from O2 center to O1, you have drawn this normal on this line, so there will be alpha angle, and from this triangle you can find the alpha. Okay, so what will be the alpha? Sine alpha is equal to O1m upon O2 O1 O2. Okay, first of all consider this triangle O1m O2 triangle, and among that sine alpha is equal to opposite side this upon hypotenuse O1 O2. What is the O1 O2? You can say O1 O2 nothing but distance between two pulley, center distance, which is you already know by the x. Okay, and what is this distance? O1m. But you can see here, this is the distance, this distance is R2, smaller radius, and same distance will be here R2, and total distance here is R1. So if I am saying that total distance is R1, and among that you want to minus R2, so this will be R1 minus R2 by x. Okay, so sine alpha will be R1 minus R2 by x. So we, for derivation, we have we taken as this large angle, but actually this angle will be very small. So when you know that when the in sine, if the angle is small, the sine theta is equal to, we can take theta, sine theta is equal to theta when the theta is very small. So sine alpha is equal to R1 minus R2. So we can write that alpha is equal to R1 minus R2. So you have find the sine alpha is equal to R1 minus R2 by x. So what is the arc J? You already know that arc J, this arc J is equal to angle alpha into radius. Radius is R1. Okay, so formula will be simple, R1 into this angle, and same will be here, for the arc FK. There will be 90 minus alpha, and here for JE 90 plus alpha. So arc JE already we have find arc J is equal to R1 into 90 plus alpha, and for FK 90 minus alpha. Okay, so now we have to find this length EF. How can we can find this length EF? Check this out, EF length is the same as O2M length. Yes or no? This length will be same. So we will find the length of O2M by what? By considering this triangle, because we know the alpha, we can find this length. Okay, let's start find the EF. So now we are going to find EF by considering this triangle O1 O2M. Okay, by considering this triangle, so EM will be under root O1 O2 square minus O1M square, and you already know that O1 O2 nothing but center distance. So you can put O1 O2 as a x, and O1m same as O1m is equal to up to this R1 total R1 minus R2. So it will be R1 minus R2. Okay, in from this you can common this x square. So when I am common the x square, it will become 1 here, and what will happen, it 1, but here no x is there, so it will become R1 minus R2 by x whole square. Okay, this equation I can write this as this, like 1 minus something R1 minus R2 by x total square, but by out of this I can write this 1 by 2, and when I am opening this bracket and I am opening this, there will be equation like this. Okay, and it will decreasing the value of terms here, x1 minus first term, second term, and power. So there is a one equation as binomial theorem, but I am ignoring the all the step behind this, which is very small. Okay, and I can write this equation simply as EF is equal to x minus R1 minus R2 whole square upon 2x. Okay, so now you have find the EF, you already know the length of these two arc. So now we are going to find the total length of build drive. Okay, let's start. Check this, there are lots of steps are ahead, so pay attention. So first of all, these three data we already find that. First of all, we find the EF, arc length, both arc length. So first of all this, so 2 R1 pi by 2 plus alpha plus x minus R1 minus R2 whole square by 2x plus value of fk R2 pi by 2 minus. So first of all, open all these brackets inside the larger bracket. Okay, so what will happen, R1 pi by 2, R1 alpha, then x is the same as these two step will be same, R2 into pi by 2, R2 into alpha. Okay, clear up to this point? Check this, what we have done, there is a pi by 2 and there is a pi by 2, so we will common the pi by 2, and same as here there is a alpha and here alpha, we common the alpha, so R1 minus R2. Okay, and what we have written here, multiplying the 2 inside. So after multiplying the 2, what will happen, so we are going to open this bracket and 2 will be multiply all the terms inside the bracket. So 2 will be removed, 2 is multiplying, 2 is multiplied, and 2 is removed. So check this out, this equation, this up to this step, and you can write this step in a simple manner, putting the value of alpha. Okay, we have put the value of alpha, R1 minus R2 by x, we have put it here. So what will happen, R1 minus R2 by x into R1 minus R2, what will happen, R1 minus R2 into R1 minus R2, it will become R1 minus R2 whole square. Okay, so pi R1 plus R2 plus 2 R1 minus R2. So you can see here these two terms are same. Here is a positive 2 and is a positive 2, and here is a negative. So what will happen, plus 2 minus 1, it will become positive plus, okay, 1. So pi into R1 plus R2 plus 2x plus R1 minus R2 whole square by x, and it is your final length of open belt. Okay, which will used in all the example of belt drive. So this theory total needs lots of practice, and you have to practice 2 or 3 times so you can understand it properly. Okay, so same, this is the length of open belt. Okay, same type of method used in a cross belt. Okay, and you can see here the belt will cross from this point and then up to this way. So length of belt is a higher than open. So what is will be difference? You can see here there is a minus in this equation. First of all, pi by 2 d1 plus d2, pi by 2 d1 plus d2, 2x d1 minus d2 square upon 4x. Remember that there is a minus is there, only one minus is there, okay, d1 minus d2. And in cross build, check this, there is a plus, only difference is that same method you can derive this, okay. So we are not explaining this theory. Check this, first of all complete the open belt drive, length of open belt, and then you can check this cross belt. Only change will came here, it will be plus, okay. Okay, let's start power transmitted by belt. Very simple and very one small point which will used in numerical. So you can see at the tight side T1 tension in a tight side, and there is a slack side, and T2 is a tension in a slack side. So we kept the slack side always on the top of the top side, so more angle of contact we can obtain, and larger the friction, more torque can be transmitted. Okay, so what can the power can be transmitted by belt is totally depend on the tension. So you know that the tight side T1 is a tight side and T2 is a slack side of the belt, but difference between these two tension is a main point for the power transmission. So effective turning force at a circumference is the difference between the two tension. So and it's also depending upon the velocity. So work done per second will be T1 minus T2 is a force, one tension, into velocity. So Newton into meter per second, and you can also write that as a watt, which is the unit of the power. So this is the main very important formula which we will use in a example. So power is equal to T1 minus T2 means effective tension, okay, means difference between two tension into velocity of belt, okay.